Sometimes it acts like a wave, other times like a particle, and sometimes it doesn't seem to be anywhere until we look. The fastest thing in the universe. It can travel across galaxies, bend around stars, and even get trapped.
So, what is light, really? And wait, how can something be real only when we look at it?
Today, we'll explore the bizarre truth behind light, how it moves, bends, vanishes, and even shows us the past. Let's start simple. You flip a switch, the bulb glows, you see light. Easy, right? But that glow is made of tiny packets called photons, each one a little burst of energy. And unlike anything else, photons have no mass. That's why they travel at the speed of light, nearly 300,000 kilometers per second. But here's the twist. Light doesn't just move like a stream of particles. It also spreads like a ripple, like tossing a stone into a pond.
So, it's like light is doing two things at once?
Exactly. It's a quantum mystery. Sometimes it behaves like particles, other times like waves. This is called wave-particle duality. And it's not just weird, it's fundamental to how reality works.
That's fascinating. I'd love to learn more.
Let's follow light on a journey. You step outside. Sunlight hits your face. But that light, it left the sun 8 minutes ago. You're seeing the past. Now imagine a photon heading toward Earth. It passes through space, no resistance, full speed. But as soon as it enters water, it slows down.
Wait, light slows down in water?
Yep, it's like hitting traffic. Photons don't actually lose speed. They're delayed as they interact with water molecules. But the moment they exit into air, they go full speed again. It's why a straw in a glass looks bent. Light gets stuck just long enough to trick our eyes. And speaking of eyes, what we see is just a sliver of what light can do. Our eyes catch visible light, red to violet. But light exists way beyond that, from radio waves the size of buildings to gamma rays smaller than atoms.
So we're basically blind to most of the universe?
Pretty much. Bees see ultraviolet, snakes detect infrared. Humans, we're tuned to one tiny window. But with special instruments, we've seen light from the beginning of time, the cosmic microwave background. It's the ancient glow left over from the Big Bang, almost 14 billion years old, stretched and cooled as the universe expanded. Now here's a mind-bender. If you could travel with a photon, time would stop, literally. To light, its journey from a star to your eye is instantaneous. It doesn't experience time at all.
Hold on. Light doesn't feel time?
Right, because photons don't have mass. Einstein's relativity says time doesn't pass for them. So in a way, that starlight you see tonight, it feels like it just left, even if it's been traveling for 1 billion years. This isn't just cosmic poetry. It has consequences. Without light, you wouldn't exist. Plants couldn't grow. Time wouldn't flow as we know it. Even your brain depends on light. It builds mental images when your eyes are closed. That's why you can see in dreams or hallucinate after staring at a bright light. Your brain uses light signals so deeply, it sometimes fakes them. And here's something wild. We've found ways to trap light. In special mirrors or tiny glass loops, photons can bounce around for weeks without escaping. But forever? Not yet.
So, can anything go faster than light?
In normal space, no. But in warped space, like in sci-fi warp drives, maybe. The speed of light is a speed limit, but only within space as we know it. If you bend the rules of space-time itself, who knows?
So, what is light?
It's a wave.
It's a particle. It's energy with no mass and no time. It lets us see the world, glimpse the past, and maybe, just maybe, bend the future.
And all that from flipping a light switch?
Yup. Every flicker, flash, and starlit sky is a glimpse into something deeper, not just physics, but the strange, beautiful rules that shape everything we see.
Hit like
Subscribe
and ring the bell.
so you never miss another bright idea.